Today's webinar will be on HSS tips and tricks. This is actually a continuation of my series that we have done on tips and tricks. 2 weeks ago being on 2.5D, last week being on HSS, HSMR and HSM, and this week it's on HSS. Now, as usual, you will be able to ask questions at the end. All you have to do is just click on the raise hand sign, and in the question area, don't forget, all you have to do is write the question. And when you finish writing the question, most important is to click on the send button so that I can actually get the questions at the end, so I can answer them at the end at the best of my abilities. Okay, so let's start with the webinar. Today's webinar is actually not going to be a long webinar, but it's going to actually be quite interesting because there are a couple of options that we have in HSS that not everyone knows about, and there's a couple of tricks we can also use with HSS which is worthwhile looking at. The first thing I'd actually like to talk about in HSS is one of the simple operations we have there, an operation called parallel cut linear, a linear operation. Now, in our typical linear operations, what would whether it would be, say, for example, in HSM, when we do a linear operation on steep areas, such as this area over here, usually the linear operation does not work as well in steep areas. But in HSS, actually, when you're using a ball and mill, what we'll see actually here is that the step over that you're going to have is actually according to the actual surface condition. So you'll get a much more even tool path along no matter what the surface condition is at that particular point. Let's actually take a look at an operation. I'll start a new HSS operation and use the option of parallel cuts linear. Now, I'd like to actually use a parallel cut going back and forth on this surface over here, this around over here. That's the surfaces I'd like to work on. So I'll create a new geometry using those surfaces. I'll just pick my surfaces over here, go around the part, choose them as I need them, continue on down until I get all the surfaces I want to work on. And we have this one over here, this one, and this one. Those are the surfaces I'd like to work on. Let me just show you with them again. And as you can see, those are the surfaces that I'm going to work on. Okay, now, the tool that I'm going to use is going to be a 6mm ball and mill. Important to note that I'm using, in this particular case, a ball and mill to do these operations. Now, next, levels, we'll leave that exactly the way it is right now. And in my toolpath parameters, we have our step over, but note what it says. It doesn't say step over. It says maximum step over. That's because in this particular case, when we're using a ball end mill, we actually have the scallop controlling our step over. So we'll get an actual even tool pass over the part itself. Let me just go into our link, and I'm going to use right now for our gap. Since there is a gap going between this point and this point, I'm going to have that go as direct. And at the end of the slices itself, I'm just going to have them blend. Let's take a look at the tool paths that have actually formed over here. And if we look at it closely, one more thing, I'd like to actually work going 90 degrees. So I'll go back in my geometry, define my angle at 90 degrees. I'm going in the Y direction. We'll take a look at the tool path now. And as you see, it's going back and forth. Let me actually do it a little slower so you can see the actual tool path as it's forming. You see it's going back and forth across the part over there, across the surface. And now to actually take a closer look at the surface itself. You'll note that the step over, no matter what surface, whether it be on a steeper angle over here over here, or the flat surface over here, the step over is actually even according to the surface condition itself. This is something people don't always know about the linear in HSS. It actually gives you an even cut around the actual surface. You'll get a very good surface finish even in the linear on the steep areas over here as well. That's one thing I wanted to point out with the linear. Now, just one more note also. Going across over here, I chose also the option of going directly from this point to the next point. In other words, my large gaps, I told it to go directly. What many people actually would prefer doing is actually lifting itself up, because not always can you do this. You're actually going up a little bit and then going over to the other side and then going back in. Well, the way I'd like to do this is actually I like to, when I get to this edge over here, I'd like to actually go up with a lead out of an arc, and then back, and then lead back in with an arc, with actually a vertical arc from the top, and then go to the other side. But I'm going to do it in a very specific way. I'm going to go into my option of link, and then with my direct link, I'm going to use the option of, instead of leaving it at don't use lead in, lead out, I'm going to use the option of use lead in and lead out. Now, when I do that, let me go into the option of lead in and lead out over here, and I'm going to change it from my default, which is normally a tangential arc. I'm going to have it go as a vertical tangent arc coming in from the top in. Now, I also don't need a complete 90-degree turn in. I'm just going to limit this now to 45 degrees. Let's just click on OK. And we'll take a look at our toolpath over here. Excuse me. Still is a little slow over here. And now, first of all, it's going back and forth. Now, as it's getting to the area where it has to leave the part, note it goes up in a radius above the part itself, and then goes across to the other side as well. Okay, now as it's going to the other side, you can see it's going down now, goes up, but I want the feed actually to go quicker when it goes across to the other side. So I can do the following. Instead of having it direct, let me change the large gaps to safety distance. Now, when it goes up to the safety distance, then it'll take a different type of a feed. If I go now into my tool and go into my tool data, we have our retract feed. Let me change my retract feed to, say, 4,000. And let's take a look at what happens now with the toolpath. It's going across. Okay, now let's first zoom into this area. You see it retracts with the arc, then goes up just a little bit to the safety distance. But now look what happens when it goes on my feed when I'm working in that particular area itself. Let's continue now. I'll do it one step at a time. As you see, it's going across right now. It's at 1,000. It goes up. Now when it gets to the top over there, look what happens to the feed. The feed automatically changed now to 4,000. And now when every single time it works across the top over there, it's going on that faster feed if I want to do it that way. So we also have complete control as far as the lead out the way I want to have it. I don't have it going directly on the material. Plus I have it going a little bit above so I can go from one side to the other a lot quicker as well, instead of going directly across to the other side. Okay, let's stop this particular part. Now I'd like to go to the next part that I have over here. So I'll close this part. And I'll open up a different part instead. And what I'd like to show you in this next part, as soon as I open it, is actually there are three different options I'd like to show you. First, I'd like to show you also as far as working on these surfaces over here. I'd like to work on these surfaces, but the way I'd also like to work on these surfaces, since it's actually going straight down, again, I'd like to have the option of the equal step over according to the surface condition. In this particular case, where I have these flat walls over here going all the way straight down, the best way to get that done correctly in this particular case is using what we call morph between two surfaces. Let me start the operation itself. And I'll start by using the option morph between two adjacent surfaces. My geometry, my drive surfaces will be this surface, and that surface. Those are the surfaces I want to work on. And my two adjacent surfaces will be as follows. The first one will be the top one over there. And my end edge surface will be this one over here, which is the border of this particular surface over there as well. I'll use my ball end mill as I used in the previous operation. And if I go into my tool path parameters, I'll have it go 1 millimeter now so we can actually see the steps. Let me go into my sorting. In this particular case, my sorting actually my cutting method will actually work very well using spiral, going around the part itself, continuously going around. Let's just do a quick save and calculate and run my simulation. Excuse me. As the calculation finishes now, we'll run the simulation, and you'll see the following. The tool is going around, and I didn't have to worry, since I chose the option of spiral. This particular case, I was actually able to use spiral without any kind of problem. You'll first of all note that as it goes down on the part, the spacing will always stay the same between each cut. So again, I'm going to get that even surface condition along the entire part, whether it be this shallow area or this complete steep area as well. You're going to get that entire area over there with that even cut on the surface itself, according to that same surface condition as we go on the part. No matter what, it may look closer to here, but if I actually work on the side, you'll see it's actually keeping that same distance as it goes around that particular surface. So again, we're getting that equal cut, equal surface condition on the entire area over there, on that entire surface. Now, so the best way to get that even cut in this particular case is what we call morph between two surfaces. Now, let me continue actually in this part, and I'd like to actually work on these surfaces around here using the option of parallel cuts constant Z. Okay, perfect example for doing that. Now, we'll have the option, as I said, parallel cuts constant Z. I'll choose my geometry. And my geometry, as I said, will be these surfaces around the part over here, this one here, that one there, and that one there. Basically, I have all the surfaces. Note with each one of these surfaces, there's actually a gap between them. Take that into account for a moment, because you're going to see what actually happens and how it actually works with that gap, and how I'm going to make the changes to make it work a lot better. Okay, let's continue with the ball animal as I had before over there. And let's go into our toolpath parameters. We have maximum step over. Let's keep our sorting right now. We'll keep it actually this way, zigzag. Let's have our links. We just leave it exactly the way it is right now. And of course, what's going to happen when it goes around, let me do this slowly. You see what happens? It actually goes around, but every single time we have that gap, it jumps up to its clearance level. Now, I can start fooling around with my leads, going back and forth, which way I want to work with it. But let me actually try something else. Instead of working from one on the passes itself, let me go into my links area itself. And we have in my toolpath parameters, in my sorting, we have the option over here of machine by lanes or regions. The way we did it right now was lanes. So it just kept on going in that constant lane around the entire part. And since it had a break over there, it just continued on to the next part by going up to its clearance level. If I were to break it into regions instead, then it'll work only on that particular surface itself and then go to the next area. Let's take a look at the toolpaths we have over here now. You'll see that it's working on that particular surface over there. And when it finishes, then it goes to the next surfaces, and it's not jumping up all the time anymore. It's just going once to its clearance level, and then it finishes that area over there, goes to the next area, finishing off each area exactly the way I wanted. Now, we finish this off all the way to the end, but you know what? I don't want to really jump up all the way every single time. In fact, I would like to change the way I'm working going to my clearance plane. Well, I just said a magic word, plane. What do I mean by that, that magic word? Let's go into our levels. We have here clearance area going up to the plane. But you know what? This is a part, if I'm looking at it from the top, it's actually cylindrical, the way I'm working around it. So let's change this. Instead of plane, let's use the option of cylinder. The clearance area being around a cylinder parallel to my Z level. In other words, we have this cylinder around my Z level. Now, the radius I have on this part down here is actually 48 millimeter radius. So let's put in a radius value over here of 50 millimeters away from the part itself. Let's see what happens now if I leave it as far as clearance area to the cylinder itself instead of to the plane. We take a look at the simulation. Again, it'll start exactly the way it did before. But note first that when it came down to the cylinder clearance area. Now the cylinder itself is being considered the clearance area. Going down. Now when it goes to the next area, it doesn't go up. Instead, it goes to the cylinder area around it. Its clearance is now controlled by a cylinder instead of a plane all the way up on top over there. As you can see, it goes all the way around to the very top. If I take a look at this top view, you can actually see it's clearing around to the cylinder itself instead of going all the way up to the top. This actually makes for a lot more efficient type of a toolpath as it goes from one area to the next. And that's just by going into my cylinder and have it going according to cylinder instead of plane around Z level in this particular case. Let's see, by the way, if I read my retract distance, if I make my retract distance a lot less, say 5. You can see also the retract is a lot less as it goes out over here, and it goes more directly even to that next surface instead of going up as much as it did before. So all of this could control this and get you actually a lot shorter tool paths in between each one of those surfaces. Okay, now let's move on to our next option that I want to show. And in this next one is actually a little bit of a trick I've seen actually using 5-axis, and I want to use it in HSS as well. We have what we call in HSS gouge control. Now, gouge control is always meant for what? For controlling the fact of how you, to make sure you do not touch surfaces that you don't want to machine. But in this particular case, I'm actually going to show how I can use the gouge control to actually machine what I want to use it on the surfaces that I want to machine. Now, what do I mean by that? Well, let's take a typical case. If I had what I would like to do on this surface over here is do a linear cut going across the surface over here. Now, if I were to do a linear cut using these surfaces as my drive surfaces, all of these surfaces over here, what's going to happen is it's gonna do it. But first of all, when it gets to these areas over here, you're gonna have sharp turns, so then I have to worry about as far as how it connects from one to the other. Sometimes I have problems with the direct cuts according from one side to the other, and I have to fool around a lot with it in order to get a good cut on it with the linear. Actually, while I'm talking, let me actually open up the operation that I want to do, the parallel cuts linear. Now, let's take something else theoretically. If I have a flat surface, completely flat surface, not this thing, and I would do a linear cut on that, that would give me a beautiful tool pass. For example, if I were to choose my geometry, my drive surface, as this floor over here, let's forget about the very top for a moment, okay? If I were to use that floor over there, well, since I'm using the floor, let me just check what my direction is, because normally direction is in the other direction over there. So let me just flip it around, because I'm working from the top, okay? If I want that surface, the type of tool pass I'm going to get is actually going to be very straight without any kind of jumps, really. Let me show you what I mean. Let me actually have it so you can see it is a lot nicer. I'm going to have my define angle at 45. I'm going to use my tool 6mm ball end mill. And my levels, I'll just have that go. My toolpath parameters every millimeter. And in my links, I'm just going to have my large moves over here blended at the very end. Let's take a look at the actual tool pass I'm getting. And if we take a look at the tool pass, let's take a look at the bottom actually. You can see that we have the tool pass itself is nice. There's no jumps on it, obviously. But now, obviously though, I don't want to machine that surface. I want to get that type of a tool pass, but going over this. So what I'm going to do is I'm going to leave that bottom surface as my drive surface. But instead, I'm going to go into my gouge check. And I'm going to enable my gouge check. And I'm going to say, okay, you know what? I want you to do a gouge check on these surfaces, the actual surfaces I want to machine. Those are surfaces I want you to do a gouge check on. Okay, we'll choose these as well. This one over here, this one over there, this one over there, and that surface over there. Those are the surfaces I want to do a gouge check on. Basically everything I do over the top, what you would think is actually my drive surfaces, I'm actually using that as my gouge surfaces. And in my strategy, what I'm going to do is very simple. I'm going to change this to move tool away. When it sees this, to move the tool away from the surface itself, and it's going to move normal to that bottom surface. So the result is it'll actually look something like this. In a moment we'll see it. Now it's also important to have make sure your tool tip is marked off over here, tool shaft. You know what, I'll redo this again. I'll even put my tool arbor to make sure nothing actually sees that particular surface. Let's run my simulation now in a moment. Here we go, we'll run our simulation slowly. And as you can see now, instead of running through the surface, going down to the bottom, since this is a gouge protected now, And so it's retracting to this surface. But it's taking the path of the actual surface on the bottom, but on top of this surface instead. So what you're getting, the result is, you're getting that really nice linear, straight linear toolpath without any kind of jumping, just going over this area itself, giving you that really nice toolpath you're looking for in this particular case. So this is actually a good way to get these kind of variable shaped surfaces to give you a nice toolpath without fooling around with the links or gaps or anything else like that, or these particular corners as well. Okay, one more part I'd like to bring up over here. We'll load one more part and something called an option that we have inside HSS of roughing. Now, what I'd like to do is actually machine these three stubs. Let's actually first concentrate on one of them. What I'd like to do first is have the tool go along this edge on the bottom over here around that stub itself. So I'll start an HSS operation, and this time I'll use the option of projection user define. By projection user define is what I'll do is simple. I'll just pick the surfaces that I wanted to go on, that I'm relating to. These particular surfaces around the bottom over here. Let me just zoom in, make it a little easier to pick. Choose that over there, that one over there as well. This one here, that one, and this one over there. Those are the surfaces I want to work on. The projection curve is actually going to be, let me just get this back to where I was before, is going to be this curve around here. In other words, the center bottom of the tool is actually going to run on this edge over here. I'm going to go around the part, pick each edge that I need, going all the way around. Getting to this edge over here, this one, and then this one over there. And we have our chain at the bottom over there. I'll use my end mill that I need, my ball end mill of 10 millimeters. And let's just do a quick save and calculate. Take a look at the actual tool path that we're going to get. And as you can see, let me slow this down. You can see the tool goes down around exactly on that edge itself. Okay, that's fine, really nice. Now, what I'd really like to do is I'd actually like to do this, but actually going down in several steps all the way going down. Not all at one shot, but doing it in several steps going down. So for that, I'm going to go into my roughing and more. Now, in roughing and more, I'm going to use the option of, since I want to do different, in several depth cuts, I'm going to use the option of depth cuts. Now, in my depth cuts, I'm going to use, let's say I want to go down I want to do a total of 10 different cuts, each one being spaced at 5 millimeters apart from each other. Let's take a look at what the result of this particular result we'll get from this particular tool pass. You see it's going down from the top, and every 5 millimeters it's going down following that particular tool pass, according to the shape of that edge over there, as it goes all the way down. Now, I'd like to continue actually and do one more thing. Instead of just going down, I'd actually also like to work from the outside in as well, clearing material that I may have from the outside going in. Well, for that then we have multi-passes. So I have my depth cuts, and I'll continue also at the same time, also using the multi-passes. Now, in my multi-passes, let's do roughing passes. Let's do roughing passes, a total of, let's say 5 roughing passes, each one of them being 3 millimeters apart. And what I'd like to do after that is my final 3 passes after that being 0.2 millimeters apart. Now, note one more parameter called sort by. We have sort by slices, as shown over here. It goes 1, 2, 3, or sort by passes. Let's do sort by passes. So as it goes, it will do first the top one, then the second and the third, and so on and so forth. Let's take a look exactly what happens over here. The result is as follows. It goes around exactly the way I wanted it to, but with 3 step-ins exactly the way I wanted to have it. Let's take a look actually from the top over here, and you can see we have those passes going in each time, plus we have the steps going down as well. Okay, and here we can see it actually a lot better. We have this 1, 2, 3, 4, 5 steps at 3 millimeters each, and then we have 3 more at 0.2 millimeters over there. Now, I'd like to do one more thing, however, on this part. I want to do this not on 1, but I want to do this on 3. Well, for that, we always have our option, SolidCAM option that we've always had of transform. Let me just measure the distance between this point and this point over here. Total of 80 millimeters. So what I'll do is I'll right click and I'll open the option of transform, and we'll go to translate matrix. Now, since it's in my Y direction, so I'll use number of copies 3 with a distance of 80 millimeters in between each one of them. Let's just click on OK. Let's run my simulation now, and you'll see the following. Let me put this isometric so you can see it a lot better. You can see it's doing this one, then it's going to do the next one, and then do the one after that. So I didn't have to do 3 different operations. I was able to do this all in one, just using the simple option of transform that we have inside SolidCAM. Okay, as I said, the webinar is relatively a lot shorter than I usually have it, but it was actually there are a few options I want to cover in HSS. Okay, I think we're basically done now. If there are any questions, you can still feel free to ask it in the next minute or two. Also, the webinar will be available on our website, and the parts to the webinar will also be on our website as well. If you just go into our site and you can see our site over here. If you go into our webinars, webinar recordings, you'll always have the last 4 websites that I had over here. For instance, this was the last one, tips and tricks. So you can see we have tips and tricks over here. This is for viewing. This is for downloading the video, and this is for downloading the parts used in the webinar itself. And the one I did today, you'll have the exact same method: viewing, downloading the video, and downloading the parts as well. Okay, thank you very much for joining the webinar. I hope you enjoyed it, and see you until our next webinar. Have a great weekend as well. Take care, everyone.